Hello everyone, welcome to Harshi Eclass. I am Rani. Today we will solve Class 6 Mathematics Chapter 3 Playing with Numbers in that Exercise 3.5. Exercise 3.5, question number 1. Which of the following statements are true? A. If a number is divisible by 3, it must be divisible by 9. It is a false statement because we know that 6 is divisible by 3. But 6 is not divisible by 9. So always it's not possible to divide the numbers which are divisible by 3 are divisible by 9 is a false statement. B. If a number is divisible by 9, it must be divisible by 3. It is a true statement. 9 is divisible by 9. Question 1 will come. 9 is also divisible by 3. 3 3s are 9. C. A number is divisible by 18 if it is divisible by both 3 and 6. It is a false statement. For example, 3 and 6 both can divide number 6. 6 divided by 3 is equals to 2 and 6 is also divisible by 6. Question 1 will come. But 6 is not going to be divisible by 18. 6 is not going to be divisible by 18. So it is a false statement. D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. For example, 180 divided by 9. Question 20 will come. 180 divided by 10 gives 18 question. 180 is also divisible by the product of 9 and 10. That is 90. Gives question 2. It is a true statement. If a number is divisible by both 9 and 10, then it is also divisible by 90. Their product 90. E. If two numbers are co-primes, at least one of them must be prime. Co-prime numbers are the numbers which have only one as a common factor. This statement is a false statement because 15 and 16 both are composite numbers. 15 and 16 both are composite numbers. Check the factors of 15. 1 15s are 15, 3 5s are 15, 5 3s are. Factors of 15 are 1, 3, 5, 15. Now factors of 16. 1, 2 8s are, 4 4s are, and 16 1s are. These are the factors of 16. Common factors of 15 and 16 are only 1. So 15 and 16 are co-primes. But 15 and 16 both are composite numbers. 15 and 16 both are co-primes and both are composite numbers. There is no prime number in these two numbers. So this statement is a false statement. F. All numbers which are divisible by 4 must also be divisible by 8. Here 12 is divisible by 4. 12 divided by 4 gives 3. But 12 is not going to be divisible by 8. 12 is not divisible by 8. So it is a false statement. 4 is divisible by 4. 4 ones are 4. But 4 cannot be divisible by 8. G. All numbers which are divisible by 8 must also be divisible by 4. All numbers which are divisible by 8 must be divisible by 4. It is a true statement. For example, the numbers which are divisible by 8. Those are 8, 16, 24, 32. All these numbers are divisible by 4. 4 twos are 8. 4 fours are 16. 4 6 are 24. 4 eights are 32. So, all these numbers, all the numbers which are divisible by 8 must also be divisible by 4. It is a true statement. H. If a number exactly divides two numbers separately, it must be exactly divide the sum. Here, if a number exactly divides two numbers separately, the two numbers, imagine 4 and 6 are the two numbers which are divisible by 2. Which are divisible by 2. It must be exactly divide the sum. Now the sum of 4 and 6 is 10. 10 is also divisible by 2. 10 is also divisible by 2. Here 2 can divide 4 and 6, both the numbers separately, and also it can exactly divide the sum of 4 and 6 without leaving any remainder. It is a true statement. I. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. Take two numbers, for example 5 plus 10. Sum of 5 and 10 is 15. 15 is divisible by 3. 15 is divisible by 3. But 3 cannot divide 5. But 3 cannot divide 5 without leaving any remainder. And also 3 cannot divide 10 without leaving any remainder. Here the sum of the numbers is divisible by 3. But the two numbers are not going to be divisible by 3 separately. It is a false statement. Question number 2. Here are two different factor trees for 60. Write the missing numbers. Write the missing numbers. 60. 60 we can write as 6 into 10. 6 tens are 60. 6 and 10 both are composite numbers in factor tree. Factor tree ends with prime numbers. Now 6 can be written as 2 3s are 6. 2 and 3 both are prime numbers. 2 and 3 both are prime numbers. Now 10 can be written as 5 2s are 5 and 2 both are prime numbers. So the prime factorization of 60, based on this factor tree, the prime factorization of 60 is 2 multiplied by 3 multiplied by 5 into 2. 2 3s are 6, 6 5s are 30, 32s are 60. Next B1. B1 here 60 can be written as 32s are 32s are 2 is a prime number, but 30 is a composite number, so we will divide this 30 again. 30 we can write as 10 3s are 10 3s are 30. 3 is a prime number. 10 is a composite number. 10 can be further divided and expressed in prime factors as 5 2s are 5 and 2 both are prime numbers. Now the prime factorization of 60 we can write as 2 into 3 into 5 into 2. 2 3 5 2. 2 3s are 6, 6 5s are 30, 32s are 60. Third question. Which factors are not included in the prime factorization of a composite number? 1 and the number itself are not included in the prime factorization of a composite number. Because take a prime number, for example 13. Prime factorization of 13 is 13 ones are 13. 13 prime factorization we can write as 13 into 1 only. not more than that. Whereas the prime factorization of a composite number, for example, take 15. 15 is a composite number. 15 is an odd number, so it is divisible by 3. 3 5s are 15. Then 5 1s are 5. What is the prime factorization of 15? 15 prime factorization we can write as 3 into 5. Here 1 and the number itself are not included in the prime factorization of composite number. Fourth question. Write the greatest 4-digit number and express it in terms of its prime factors. The greatest 4-digit number is the greatest 4-digit number is 9999. 9999. Prime factorization of 9999. It is ending with odd number, so it is not divisible by 2. We will check with 3. 3333 gives 9999. Again this number is divisible by 3. 1111 will come. 1111 is divisible by 11. 11101. 11 multiplied by 101 gives a product of 1111. 101 is a prime number, so the prime factorization of 9999 is, we can write it as 3 into 3 into 11 into 101. This is the prime factorization of 9999, which is a greatest 4-digit number. Fifth question. Write the smallest 5-digit number and express it in the form of prime factors. The smallest 5-digit number is 10,000. The smallest 5-digit number is 10,000. Prime factorization of 10,000. 10,000 is an even number, so it is divisible by 2. If it is not divisible by 2, then we will check with the next prime number, that is 3. 2. 5,000 will come. 2 5,000s will make 10,000. 2 2,500. 2 1,250. It is also an even number, so divisible by 2. 2 625. 625 is ending with 5, so it is divisible by 5 only. 5 1s are, 5 2s are 10s, 5 5s are. 5 125s are 625. 125 is again divisible by 5. 5 2s are 10, 5 5s are 25. 25 we can write it as 5 into 5. 5 5s are 25. 5 1s are 5. So the prime factorization of the smallest 5-digit number is, how many times 2 here? 1 2 3 4. 4 times 2 and 4 times 5. We can express it as and 5 to the power of 4. R. It can be written as 4 times 2 and 4 times 5. 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 5s are. Then 16 5s are 80. 80 5s are 400. 400 5s are 2000. 2000 5s are 10,000. It is the prime factorization of smallest 5-digit number. Question number 6. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. Prime factorization of 1729. 1729. This number is ending with 9, which is an odd number. So it is not going to be completely divisible by 2. We will check with 3. 3 5s are 15. Then 22 is there. 3 7s are 21. 19 is coming. 19 is not going to be divisible by 3. After that, next prime number 5. But this number is ending with 9, so it is not going to be completely divisible by 5 also. We will check with 7. 7 2s are 14. Then 42. 7 2s are 14. After that 32. 32. 7 4s are 28. 7 7s are 49. 247 will come. Then 247 is divisible by 13. It is divisible by 13. 13 ones are 13. 13 ones are 13. 11 will be there. That is 170. 13 nines are 170. 19 is a prime number. 19 is a prime number. So, the prime factorization of 1729. 1729 we can express as 7 into 13 into 19. Here, if find the relation if any between two consecutive prime factors. The relation between these prime factors is that the difference between the two consecutive prime factors is that 6. 13 minus 7, 13 and 7. Difference between them is 6. And 13 and 19. Difference between these two numbers also 6. The difference between two consecutive prime factors is 6. Question number 7. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Let's see two examples related to this. Three consecutive numbers. Three consecutive numbers. You can write 2, 3 and 4. The product of three consecutive numbers. Here the three consecutive numbers are 2, 3 and 4. 2 3s are 6. 6 4s are 24. The product is 24. 24, is it divisible by 6? 24 is divisible by 6. 6 4s are 24. One more example. Write three consecutive numbers. Those are 5, 6 and 7. Product of these three consecutive numbers. 5 6 are 30. 37s are 210. 210 is also divisible by 6. 210 is also divisible by 6. 6 3s are 18. 6 5s are 30. Question 35 will come. Next, the sum of two consecutive odd numbers is divisible by 4. The sum of two consecutive odd numbers is divisible by 4. Verify this statement with the help of some example. Here two consecutive odd numbers, for example, take 5 and 7. 5 and 7 are two consecutive odd numbers. 5 plus 7, their sum 12. 12 is divisible by 4. 12 divided by 4 gives quotient 3. 4 3s are 12. One more example, 9 plus 11. 9 and 11 both are odd numbers, both are consecutive odd numbers. Sum of 9 and 11 is 20. 20, it is divisible by 4. 4 5s are 20. Next, ninth question. In which of the following expressions prime factorization has been done. For checking that, we need to multiply the prime factorization of the given numbers. 24. 24 is written as 2 into 3 into 4. 2 3s are 6. 6 4s are 24. 2 3s are 6. 6 4s are 24. But prime factorization means in its factors all the numbers should be prime numbers. Here 4 is a composite number. 4 is a composite number, so this is not the correct prime factorization of 24. Next 56. 56. 7 2s are 14. 14 2s are 28. 28 2s are 56. 28 2s are 56. This expression is correct. 56 can be expressed as a, and 7 2 both are prime numbers only, so that one is correct. Next C1. 70. 70 is expressed as 2 5s are 10, 10 7s are 70. This one is also correct because 2, 5, 7 all are prime numbers only, and their product also equals to 70. D. 54. Multiply and check. 2 3s are 9, 9 9s are 81. 81, but here the given number is 54. This prime factorization is not equal to 54. This is a wrong expression. This is not correct. And 9 is not a prime number. 9 is a composite number. 10th one. Determine if 25,110 is divisible by 45. Determine if 25,110 is divisible by 45. Hint is given. Hint is that 5 and 9 are co-prime numbers. Test the divisibility of the number by 5 and 9. Divisibility rules. We already learned the divisibility rules. Divisibility rule of number 5 is that the numbers which are ending with 0 or 5. Which are ending with 0 or 5. That means in its ones place it should have either 0 or 5. Those are completely divisible by 5. And the divisibility rule of number 9 is that sum of the numbers, sum of the digits in the given number, sum of the digits in the given number should be divisible by 9 without leaving any remainder. So let's check that the given number is divisible by 5 and 9 or not. 25,110. This number is ending with 0. In its ones place it has 0. That means it is divisible by 5. It is divisible by 5. Let's check with 9. Sum of the digits. Sum of the digits 2 plus 5, 7. 7 plus 1, 8. 8 plus 1, 9. 9 plus 0, 9 only. 9 divided by 9 is equals to 1. It is completely divisible by 9. That means this number is also divisible by 9. So, it shows that this number 25,110 is also divisible by 45. Is also divisible by 45. Write that. Yes, 25,110 is divisible by 45. Is divisible by 45. Question number 11. 18 is divisible by both 2 and 3. 18, which is divisible by 2. 2 nines are 18. 18 is also divisible by 3. 3 6 are 18. It is also divisible by 2 into 3 is equals to 6. That means 18 is also divisible by the product of 2 and 3. 18 divided by 6 is equals to 3. Similarly, a number is divisible by both 4 and 6. Can we say that the number must also be divisible by 4 into 6? The product of 4 into 6, that is 24. So, if a number is divisible by both 4 and 6, that means the number also divisible by 24. Is it correct? Is this statement correct? Give an example to justify your answer. Actually, this statement is not correct. Always it is not possible that the that the number also divisible by 24. For example, 12. One example is that 12. 12 is divisible by 4. 4 3s are 12. 12 is also divisible by 6. 6 2s are 12. But 12 is not divisible by 24. 12 is not divisible by 24. One more example, you can say that 36. 36 is divisible by 4. 4 9s are 36. 36 is also divisible by 6. 6 are 36. But 36 is not going to be completely divisible by 24. So, this statement is not applicable in all the situations. 12th question. I am the smallest number having 4 different prime factors. Can you find me? Smallest number having 4 different prime factors. Here the smallest number having 4 different prime factors is the product of first 4 prime numbers. The smallest prime numbers, those starting from 2 is the smallest prime number, after that 3, next prime number 5 and next 7. The product is the smallest number which is having 4 different prime factors. 2 3s are 6, 6 5s are 30, 37s are 210. Here the smallest number is 210. Thanks for watching. Like, share and subscribe to my channel.